is called a numerical method. Okay. Now, this numerical method is an iterative method. Pag sinabi mong iterative method, it's being done repetitively, no? Ulit-ulit using the same formulas but different approximations. Let me just write that down. A numerical method is an iterative method for finding approximate solutions. Approximate solutions. Okay? So, ito yung terms natin. Yung title ng course natin, Numerical Method and Analysis. So, we will be dealing with an iterative method of finding approximate solutions for equations. Okay? So, the first topic is about root finding methods. Okay, so finding the solution to an equation or finding the zeros of a function using open methods. So root finding techniques, open methods, and the other one is bracketing methods, which we will discuss next meeting. Okay, so, but before these open methods, some terms are actually very important to note here in this course. So accuracy is also very important to define. So accuracy refers to how closely a computed or measured value. Remember, our values here are just approximations, no? Computed or measured value agrees with the true value. So refers to how closely a computed or measured value agrees with the true value. Okay. So on the other hand, we have the term precision. What's the difference between the two? Term accuracy refers to how closely a computed value agrees with the true value, right? Now, this one refers to how closely an individual computed or measured value agrees with each other. So, individually naman, yung mga approximations natin, how are they related to each other? So, ganun siya, ha? Refers to how closely individual or computed individual computed or measured values agree with each other. Okay. In our solutions here, it's very important to note the stability of your method. Okay, stability of method. Because you have to make sure that your solution will guarantee that that it will converge to the root of the equation. Otherwise, you're wasting your time, di ba? So if the method does not guarantee your that it will converge the solution to the root, then wala mangyayari dun sa solution mo, magpapaikot-ikot ka lang, no? So it's very important to note or to look at the errors in your computed values. Okay, so this refers to the behavior of the errors for every iteration. Okay, behavior of errors or error for every iteration. Dapat yung error mo, yung errors natin as you go along the solution, dapat lumiliit siya, na lumiliit. Okay, for every iteration. So pag lumalaki, ibig sabihin, your solution will not converge to the root. Right? So you're just wasting your time. Now, how do you compute this error? How will you look at it? No? All right, we have okay. Sorry about that. All right. So we'll have so absolute error. One is absolute error. Absolute error, which we can denote by epsilon sub a for absolute. No, this is equal to the true value. True value, and then minus the approximated value. Approximated or the measured value. Okay, approximation. This should always be positive. That's why I enclose it with the absolute value symbol. Okay, true value minus approximation or measure. Now, in our case, we will be getting the error, the absolute error between two succeeding iterations. So what we'll be using in our discussion is the notation absolute value of delta x sub n, which is also an absolute error, but between two successive approximations. Okay, so this is x sub n minus x sub n minus 1. So what are these x sub n and x sub n minus 1? Well, delta, of course, means change, no? So change in x yan. So x sub n is, this is our current estimate or approximation. Current estimate. And then this one is our previous estimate. So if you want to know the error between two successive iterations, you use this. Okay, absolute error. And then the other one is called relative error. Relative error, which we can denote by E or epsilon sub r. And that is just the absolute error over true value. Okay, or in our case, the relative error is delta x sub n, the absolute error over the current estimate x sub n. Okay, normally I use this, yung absolute error, this absolute error for our computations. Okay. All right, now let's go to root finding techniques. The first open method that I'll discuss is called fixed point iteration. Open methods. Okay, for root finding. Or in some cases, in the root finding, in some books or some teachers will call it finding zeros of the functions. For finding zeros of functions. Okay, so it's the same thing. Root finding, finding the roots of an equation, or finding the zeros of a function. Pareho lang. Right? First one is called fixed point. Fixed point iteration. Okay. Okay, you have to write your function in this way. So write f of x equals 0. So you have to equate your equation to the expression on one side of the function to 0. Okay? Sometimes it's already written in this way. So wala ka ng problema. And then you have to rewrite your function in this form. X equals g of x. What does this mean? This means that you have to isolate x. To isolate x on one side of the equation. Okay? Because that will be the formula that we'll be using to find the roots of the equation, okay? Or to find the zeros of the function. So our formula will be based on that equation. Our formula is in the form x sub n plus 1 equals g of x sub n. Okay, so this is the formula that we are going to use. Now, x sub n plus 1 would mean the next estimate. This is the next estimate. And as I defined a while ago, x sub n is our current estimate. Okay, so to find the next approximation or the next estimate, we will be using the current estimate to be applied in this function g of x. All right, so how does this work? If I try to show you in a graph, how does it work? For example, you have a function, no? You have a function and then you equate your function to 0, equate f to 0. So you have not a function anymore, but an equation. Diba? Now, if you graph that function, f of x, for example, this is our function. Ito yung function ko. Yan yung y equals f of x. No? Now, you equate f of x to 0 kasi you want the root of the function or the 0 of the function, right? Ito yun eh. 0 ng function or the root of the equation. And bakit tinawag na 0 yung function? This is the 0 of the function kasi this is the value of the function whenever this is the value of x actually. This is the value of x whenever the function is equal to 0. That's why, ito yun, no? Ito yung f of 0 mo. Diba? So, ganun yung ginagawa natin. Now, for that particular example, for that particular formula, now, we have to write f of x equals 0 in the form x equals g of x, no? And then we will be getting, according to this method, we will be getting the 0 of the function by getting the root of this equation, no? Ano itsura niyan? Itong function na to, yung y equals x, is a line, no? That's the identity line, no? Passing through the origin with slope equal to 1. So, ang itsura niyan ay ganito. Ganyan si line. Passing through the origin. Alright. Now, this is y equals x. Okay, now, where is y equals g of x? Ito yung y equals g of x. Okay, now this is y equals g of x. Now, the point of intersection between the two will give us the root of the equation. Itong point of intersection na to, the x-coordinate of that is the root r. This is the root r. That's what we're trying to find, okay? The value of r. Now, what happens here in this iteration method is you get a value, a current estimate, and then you apply it to g. And then after applying it to G, you get another estimate, okay, that you can use in the next iteration. It's like this. You have a value of X, you apply to G, and then after applying to G, you'll be able to get another value of X for the next estimate, like that. And then you apply that new value, new estimate to G again, and then you'll be getting another estimate. Higa ako ng konti ito. Hindi nyo makikita yung gusto kong ipakita eh. Higa ako ng konti. All right. Here, and then you apply G, and then you get another estimate, and then it's the same here. You get another estimate, and then you apply again to G, you get another estimate, and then that new estimate you apply to G, and then it goes on and on until after a certain number of iterations, you arrive to this root. Diba? This is what we're trying to find. The value of R here. So, paulit-ulit lang, iterate ng iterate, tapos hanggang mapunta ka dun sa pinakamalapit na value nito. Okay, that's what this method do. Okay? And then this is the formula that we're going to use. Now, we have to ensure that this method will converge to the root of the solution. Katulad ng drawing ko kanina, minsan hindi siya papasok ng ganyan para pa-converge ka dun sa root. Okay? Minsan papalabas yung square mo. Palabas na ganun. Palaki, ibig sabihin that is divergent. So we have to ensure first, before starting the iterations, you have to ensure that it is convergent. Now, how do we ensure? You have to take note of this. So, the sequence of approximations, right, converges to the root R if and only if the absolute value of the derivative of g of x is less than 1 for all x sub n. Okay? So, dapat lahat ng value ng derivative of g, remember ito yung g natin, okay? At your approximate values, dapat lahat less than 1. Otherwise, this will not converge. So, divergent yung inyong ginagawa, no? So, hindi siya mapupunta dun sa true solution. Hindi mo masosolve ng tama. Right? Okay, so paano i-apply yan? Let's answer this example. Solve the roots of the equation x cubed minus x squared minus 2x plus 1 equals 0. Okay? Using following initial approximations. Okay, since this is a cubic equation, so there are at most 3 real roots, right? So in this case, three real roots tayo, one is negative and there are two positive roots. So for the negative root, we use the initial approximation, negative 1.5. Okay. For the first positive root, we will use the initial approximation, 0.5. And then for the other positive root, second positive root, we will use the initial approximation, 1.5. 1.5. Okay. Stop iteration. This is the criteria or the criterion when you will stop the iteration process. When the absolute value of delta x sub n or the absolute error is less than or equal to 0.0001. Okay? So ito, naka-equate na yung f of x sa 0, no? So if you are given a function instead of just simple equation, itong 0 na to, nakalagay lang dyan f of x. So you just equate f of x to 0 and then you'll have the same equation. Okay. I will just be solving for this. And then I will leave the other two to you for your practice. Okay. Ang una natin gagawin is to write, sabi dito, if you already have the function written in this way, f of x equals 0, which it already is, write it in the form x equals g of x. So isolate one x or x on one side of the equation. There are several ways to do that in our given equation. Ito yung given equation natin, no? But I will isolate x, 1x using this term, this 2x term. So I'll transpose 2x to the right side of the equation, and then we'll have 2x equals. So magiging positive siya, no? This will remain on the on one side, on the other side, x cubed minus x squared plus 1. And then divide both sides by 2 to isolate x on the left side. So you have now x equals x cubed. Unahin na natin si 1/2. 1/2 of x cubed minus x squared plus 1. Okay? Now, we have to ensure convergence. In ensuring the convergence, we need the derivative of g. Remember, this is g, no? On the other side. Itong part na to is g. Itong part na to. This is g of x. So we have to ensure convergence using that function. So we have to get g prime of x. G prime of x is, I'll just copy the constant, no? And then power rule for this two, we have 3x squared minus 2x. That is the derivative of g. Now, if I am solving for the negative root, then I will have to try, sabi dito kasi, no, the value of g prime at x sub n. Ano yung x sub n natin? Yung ating mga approximates, no? For all x sub n. So for the initial approximate, negative 1.5. Negative 1.5. So x sub 0 equals negative 1.5. Tingnan natin ano yung value ng g prime. So g prime of negative 1.5. So substitute negative 1.5 for every x there. It's 1/2 of 3 negative 1.5 squared minus 2 times negative 1.5. Using your calculators, what is the value of this? Kindly check if we'll have the same answer. It's 4.875, which is greater than 1. Excuse me. Greater than 1, so it means that this, the solution will not converge to the negative root if you use this rearrangement. Okay, if you use this formula. So this is divergent. Now, for the initial approximate for the first positive root, which is 0.5, what's the value of g prime? Absolute value pala to dapat. G g prime of 0.5. So it's 1/2 of 3 times 0.5 squared minus 2 times 0.5. Use your calculators, please. Solve for this. One-eighth. Okay. Positive dapat kasi absolute value. So it's 0.125, no? 0.125. Which is less than 1. So this will converge to the first positive root. This will converge to the first positive root using this rearrangement. So okay to. What about for the other one? So for 1.5, absolute value of g prime of 1.5, it's 1/2 times 3 times 1.5 squared minus 2 times 1.5. In my calculation, this is 1.875, which is greater than 1. So again, this will not converge to the root. Okay? So if you solve using this rearrangement for the second positive root, you will not be able to converge to the root, to the true solution. So masasayang yung oras nyo. So first, you have to ensure convergence, no? So now we can use this formula to solve for the first positive root. Okay, using this formula. Now, what about for the other two? Masosolve na natin yung first positive root using this formula. What about the other two? Now, there's another rearrangement for this, no? There's another rearrangement. You can actually isolate x from the second term, or you may actually isolate x from the first term. Diba? Kung sa first term mo siya i-isolate, so x cubed minus x squared minus 2x plus 1 equals 0. If I try to isolate x from here, from x cubed, then we'll have to transpose all the other terms to the other side of the equation. So x cubed equals x squared plus 2x minus 1. And then we have to get the cube root of both sides of the equation. Cube root. So now, x1 and x is isolated on the left side. So, kaya lang, this one is x squared plus 2x minus 1 raised to 1/3. So, ito yung g of x mo. So, g of x is equal to x squared plus 2x minus 1 raised to 1/3. Now, we have to get g prime of x. Using chain rule to, no? G prime of x is 1/3 of x squared plus 2x minus 1 raised to negative 2/3 times 2x plus 2. This is the derivative of g. Now, you have to check the value of this g prime when x is equal to negative 1.5 and also equal to 1.5. Now, dapat mag-converge na yan. So, g prime of negative 1.5. So, substitute mo lang si negative 1.5. Negative 1.5 squared plus 2 times negative 1.5 minus 1 raised to negative 2/3. Tapos, 2 times negative 1.5 plus 2. Okay, what I have here is 0.230, which is less than 1. So, convergent na siya. So, ibig sabihin, you can use this rearrangement, no? Not that. This rearrangement to solve for the negative root. And also, the other positive root, when what is the value of g prime when x is equal to 1.5. So again, 1/3, 1.5 squared plus 2 times 1.5 minus 1 raised to negative 2/3 times 2 times 1.5 plus 2. This will be equal to 0.635 according to my notes. Sorry. 1. So this is also convergent. So you can use the same rearrangement, this in asterisk, the same rearrangement to solve for the second positive. Okay? So again, I told you a while ago that I leave the negative root to you and then the second positive root. We will be solving for the first positive root. Okay. Solving for, we have already ensured the convergence, so solving for the first positive root. First positive root. So x of 0 natin or initial approximation is 0.5. And then our rearrangement is x equals 1/2 of, ano nga yung ginamit natin kanina? 1/2 of x cubed minus x squared plus 1. X cubed minus x squared plus 1. Okay. Okay, our formula is x sub n plus 1 equals g of x sub n. Okay, this is our formula. Okay, I want you to create a table, no, with four columns. So the first column is for n, second is for x sub n, third is for x sub n plus 1, and then finally the absolute error in the last column. Okay? I will start with n equals 0. Kasi ang given natin is x sub 0, right? So when n equals 0, x sub 0 is 0.5. You are given that. Okay? Now, in our solution, we have to solve for x sub 1. According to that formula, x sub 1 is equal to g of x sub 0. Diba? Whenever this is n plus 1, this is just n. So when you are solving for 1, x sub 1, then this is just x sub 0. Now, x sub 1 is g of x sub 0. Ano ba yung g natin? Ito yung g natin, di ba? It's our g of x. Okay. So g of x sub 0 is 1/2. Is g of 0.5. So that is 1/2 of 0.5 cubed minus 0.5 squared. So I just substituted 0.5 for every x here in g plus 1. What do you get? Use your calculators, please. Please participate. Ma'am, bakit po pag negative 1.5, puro negative sagot pero same yung number? Ano yun? Saan yun? Kurt, saan yung negative 1.5, puro negative sagot pero same yung number? Sa negative root. Where is that? Dito ba? Here? Here or here? Pareho. Absolute value yung iho, ha? Kahit negative pa yung lumabas dito sa loob kasi naka-absolute value symbol kaya positive pa rin yung lalabas, ha? So, dito 1.5, iba naman yung sagot eh. Dito 4.875, dito 1.875. Dito magkaiba din. I-absolute value natin to. Absolute value. I just missed the symbols. Ma'am, paano po nakukuha yung negative root? First positive and second positive root po. Okay. Sige. Kasi usually, you are talking about the initial approximation, di ba? Yung given ko na to. Yung given na to, no? Tama ba? You're talking about that? Ayun. Okay. Usually naman sa problems, ibibigay ko to, no? Kasi for the sake of ano lang, parang consistency lang, para pare-parehas tayo ng solution. Kasi if magkakaiba tayo ng initial approximation, magkakaiba din ang solution na mangyayari. So, for the sake of consistency and uniformity, ibibigay ko to. Pero nakuha yan sa ganito. Diba? We have here a cubic equation, no? Sa graph niyan, ganito siya kunwari, no? Yung graph niya, unahin na lang natin. Kunwari, ang itsura ng graph, kasi cubic siya, let's say it's like this. Ganyan siya. So meron siya dito na isang negative root, isang positive root, and then another positive root, no? So meron kang root 1, 2, at saka 3. Okay, paano mo nakukuha yung estimates na yon? We'll just have to pick some numbers, no? And then doon sa numbers ng x na yon, let's say for example, pumili ka dito sa left side ng root 1, and then pumili ka rin sa right side ng root 1, dapat yung value ng function on the left side of root 1 dapat negative. And then on the right side of root 1, obviously, the value of the function is positive. Okay, paano ko nakuha to? For example, meron akong nasa in between ano to, no? Negative 2 and negative 1. X, tapos value ng f of x. So, when x is negative 2, when x is negative 1, what is the value of this expression when x is negative 2? When x is negative 2, then magiging ano yan, negative 2 cubed minus 2, negative 2 squared minus 2 times negative 2 plus 1. Diba? Anong value niyan? Ito ay negative 8 minus 4. So, negative 8 minus 4 is negative 4. Negative 4, tapos ito ay plus 4, 0. Tapos plus 1, ang value ng function ko ay 1. Now, what will be the value of the function when x is equal to negative 1? So, ganun din. Substitute negative 1 for x cubed. Negative 1 cubed minus negative 1 squared minus 2 times negative 1 plus 1. So, negative 1 minus 1, 0 na agad. This is positive 2. Ano? Saan na ba ako? Negative 1. Negative 1. Ito pala. Negative 1 minus 1. Ano pala to? Negative 2. Tapos ito positive 2. Bakit ganun? Ano ba yung kanina ko? Negative 2 cube minus negative 2 squared minus 2 times negative 2 plus 1. Ito negative 8 minus 4. Dito pala ako nagkamali. Minus. So plus 4 plus 1. Ito ay negative 12 pala to. Negative 12 plus 8, negative 8, negative 7 pala to. Kaya pala may mali ako. Negative 7. Na kung 1 naman, negative 1, negative 1 cube minus negative 1 squared minus 2 times negative 1 plus 1. So ito ay negative 1 minus 1 plus 2 plus 1. So ito ay negative 2, 0, 1 na lang to. So if you look at this, the sign of the function changed in between negative 2 and negative 1. No? Wala itong black ko. Okay. The sign of the function changed in between negative 2 and negative 1. So, kung negative yung value ng function, ibig sabihin nasa baba siya ng x-axis. Kung positive yung value ng function, ibig sabihin nasa taas siya ng x-axis. So, ibig sabihin, kung from here, sa x negative 2, nasa baba siya ng x-axis, going to x equals negative 1, tumaas siya sa x-axis. Ibig sabihin, in between those two, nag-pass through siya sa x-axis. And there's a root in between these two numbers. Diba? So, if there is a change in the sign, in the value of f of x, then in between those two values of x, there is a root. So, ganun din dito. From a positive value of the function, if it becomes negative. So in between, there is a root. So, ganun din dito sa root 3, from a negative value of the function, naging positive, in between, there is a root. So that's how you get this. Okay? Given, yes, ibibigay ko to for the sake of uniformity in our solutions. Okay? But actually, you have to find this. In some books, this will not be given. In some books, this is given. So, depende sa given ng teacher nyo at depende sa given ng book na binabasa ninyo. Alright? So, in our case, I will give it to you. Kahit sa quiz, kahit sa assignment, ibibigay ko yan. But that's how you obtain it. Okay? Right? So, ito yung sinasolve natin kanina. What's the value of x sub 1? What I have here is 0.4375. Do you have the same value? 0.4375. 0.4375. This is x sub 1. Tama ba? Okay. Now, the yung delta x sub n. Delta x sub n is just the difference between the two, x sub n plus 1 and then x sub n. So it's just 0.4375 minus 0.5. Absolute value, so this is always positive. What we have here is 0.0625. 4 decimal places ang kinuha ko kasi po ang given ay okay, stop iteration when delta x sub n is less than or equal to 0.0001. So, hindi na importante yung makita pa natin yung next, no? Yung next na yung next na decimal number. Okay? Okay, that's how you solve, no? So, this is 0.0625. Tama ba? Okay. Mag-calculate kayo, ha? Baka naman mali na yung binibigay ko dito. Okay, now for n equals 1. Okay, so x sub 1 is equal to, we already know that, it is equal to 4375. So, kinopya ko lang yon. Now, we'll solve for x sub 2. So, yung x sub 2 naman is g of x sub 1, where x sub 1 is 0.4375. Okay, so this is equal to 1/2 of 0.4375, kindly use your calculators, minus 0.4375 75 squared plus 1. What's the value of this? .4461. Ano ba? 0.4461 o 62? So, 616 eh. So, 44616. So, when we round this off, 4462, no? 4462. 0.4462. 0.4462. And then, we solve for the absolute value, delta x sub 1. So, that's 0.4462 minus 0.4375. Absolute value, so it's always positive. Ganyan. .0087. 0087. Okay. Wala. 0.0087. Remember our stopping criterion, ha? 0087. Okay. When n is equal to 2, n sub x sub 2 is 0.4462. Now we solve for x sub 3. So now x sub 3 is equal to g of x sub 2, where this is equal to g of 0.4462. So this is 1/2 of 0.4462 cubed minus 0.4462 squared plus 1. 0.4449 is correct. 0.4449. Okay, now what is delta x sub 2? It's 0.4449 minus 0.4462. Absolute value. We'll get 13 ba? 13 yan, ano? 13. Ah? Point 13. Okay, let me just complete the table. 0.4449. 0.0013. Okay, we're not done yet. What about when n is equal to 3? So x sub 3 is 0.4449. What is x sub 4 equal to? So it's g of x sub 3, or that is g of 0.4449. So it's 1/3, sorry. 1/2 of 0.4449 cubed minus 0.4449 squared plus 1. The value of this should be 0.4451. 4451. No? 4451. Okay, 0.4451, and then delta x sub 3 is 0.4451 minus 0.4449. This is 0.002. 0002. Okay, konti na lang. Maybe in the next iteration, we'll be able to get what we want. 4451. 0002. Okay, and then x sub 5 is actually g of x sub 4, which is g of 0.4451. Okay, so it's 1/2 of 0.4451 cubed minus 0.4451 squared plus 1. I think the answer here is 0.4450. 0.4450. Okay. And then, yung ating delta x sub 4 is obviously 0.001. No? 0.4450 minus 0.4451. Absolute value. This is 0.0001. Absolute value. Okay, so we already have our answer. When x is equal to 4 here, this is 0.4451. And then this is 0.4450, and then we already have 0.0001. Stopping criterion, as you remember, is when the absolute error is less than or equal to 0.001. So we can stop here. So our answer here is this. This. So ito siya. Ito yung first positive root na hinahanap natin, which is close to 0.5. Okay? Any questions? So it's the same thing when you solve for the negative root. and the second positive root. Kaya lang, instead of using this formula, ito yung gagamitin natin, no? Yung ibang rearrangement ang gagamitin natin. So, ito yung magiging G natin. Any questions for the first method? So, what I want to see, if ever na magpa-solve ako itong table na to. I want to see this table. Okay? Di pa po yung final answer. Yan na yung final answer, Iho. Ito yung answer mo actually. Ito yung iterative solution mo eh. Yung last step mo, yung x sub 5 mo, yun yung sagot mo. This is the approximation of the first positive root. Eh, meron ka pang dalawang roots, di ba? Sabi ko kayo na yung gumawa nun para may practice kayo. So, meron ka pang negative root, you still have another positive root. So iba yung solution doon, iba yung solution dito. Okay? But for this particular root, this is your final answer. Because we have already obtained the stopping criterion over here. Ma'am, after po makuha yung 0.0001, tapos na. Yan yung sagot mo. Ito na i-checkan ko sa dulo. Okay? Ma'am, question. Saan niyo po ipopost pala yung PDF po, ma'am? Sa announcements later after the conference. Okay, any other question? May dalawa pa tayong methods. Isa pa lang yan. May question pa yata. Okay, wala na. Alright. Tuturo ko sa inyo yung kung paano gamitin yung calculator nyo for the next formula or next method. Second is yung what we call second open method, Newton-Raphson. Newton-Raphson. Method. Okay. Newton-Raphson method naman uses derivatives. Okay, in the formula. Kasi it's like this eh. Say you have a function. Okay, this is the function y equals f of x. And you want to get the zero of this function. So you want to get this root r. So you want to get this r, the value of r. So this one uses derivatives or slopes of tangent lines. So let's say, for example, you start with this x, this initial approximation. This is x sub n. Okay. Now, a line tangent to that or a line passing through that particular point at exactly once lang, no, is like this. Okay, nag-pass through siya dun sa point na yun, no? Now, this right here, this value right here is actually the next approximation. Ito yung x sub n plus 1 mo. Okay, now this forms an angle theta with the x-axis. This angle theta. Now, we'll use the slope m of that particular line is equal to tangent theta, no? So tangent theta is equal to opposite over adjacent side, no? Or slope is actually rise over run. Run. Ito yung rise. Ito yung rise. Ito yung run. Diba? So the rise, since this is f of x, the rise is obviously f of x sub n because of this value of x, no? Yun yung rise. Now, yung run natin dito is actually x sub n minus x sub n plus 1. Ito yun, no? X sub n minus x sub n plus 1. That's the length of this. Kung meron kang triangle na nakikita, that is the base of the triangle, no? So, tangent theta, from there, tangent theta is equal to rise, which is f of x sub n over run, x sub n minus x sub n plus 1. Okay? Now, since that is a tangent line, tangent to the curve, tangent theta is actually, or the slope of that particular line is actually referring to the derivative of the function. Okay, at a particular value of x, which is x sub n. So that is pertaining to f prime of x sub n. Okay, that is equal to f of x sub n. I'm just deriving the formula x sub n plus 1. And then manipulate the equation, solve for x sub n plus 1. By cross multiplication, you'll have x sub n minus x sub n plus 1 equals f of x sub n over f prime of x sub n. And then solve for this. Ta-transpose ko sa kabilang side, ito lipat ko doon para maging positive to, no? So you'll have x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. Ito yung formula natin. This is the formula that we're going to use. It involves a derivative, no? So formula. Okay. Tuwan ko kayo sa calculator later on. Okay, using the same example, let's solve for the first positive root ulit, no? Use the example above. So that's x cubed minus x squared minus 2x plus 1. Okay, find the first positive root. Okay, using the initial approximate 0.5. Stopping criterion. When the absolute error again is less than or equal to 0.0001. Alright? So, kanina nakailang iterations, naka 1, 2, 3, 4, 5. We have 5 iterations a while ago. Tingnan natin kung sino mas mabilis sa kanila mag-converge. If this will converge quickly than the other method. Okay? Again, let's create a table that contains 4 columns for n, x sub n, x sub n plus 1, and the absolute error. Okay, let's start with 0 and equals 0. Using our formula above, so x sub 1 is equal to, if you're solving for x sub 1, this is x sub 0, right? N plus 1 ito, n yun. So dito pala 0 ito, tapos ito ay 0.5. Okay? So this is x sub 0 minus f of x sub 0 over f prime of x sub 0. Okay, we'll be needing f prime. Ito yung f natin, ha? Ito yung f of x. Okay, what is f prime muna pala? What is f prime of x? F prime of x is the derivative of this. So it's just 3x squared minus 2x minus 2. Ayan lang yung f prime natin. Okay? So what is x sub 0? It's 0.5 minus f of x sub 0. So we substitute 0.5 here. So that's 0.5 cubed minus 0.5 squared minus 2 times 0.5 plus 1 over f prime of x sub 0. So ito naman, we have to substitute 0.5 here in this derivative. So that's 3 times 0.5 squared minus 2 times 0.5 minus 2. Okay. In your calculator, para hindi mo siya paulit-ulit i-type, it's like this. So for those who are using Casio, I can help you kung ibang tatak yung ano mo, kung ibang tatak o non-linear sakop nito, yes. Kung ibang tatak yung iyong calculator, hindi kita matutulungan kasi hindi ako marunong gumamit ng ibang calculator. So, ganito sa calculator nyo, ha? Hawakan yung calculator. Kala, kunin ko yung akin. Dito sa calculator. Yung calculator nyo, nagsosolve yan ng x, ng variable x. If you try to write an equation, okay, in your calculator. So, sa calcu, on the left side, you write x. So, shift alpha, alpha tapos x. So, ganito yung isulat nyo sa calculator. X equals. So, para makuha yung equal sign, alpha ulit, tapos yung calc. Sa upper left, yung calc. Para matype yung equal sign. Tapos, you have a variable here, another variable to. Kasi this x sub n plus 1 is different from x sub n, di ba? You can write, you can use whatever variable that you like. You can use variable y, you can use the variable a. But in this case, I'll use a. Okay, type a, tapos minus f of x sub 0 dito, no? Yung f natin ay this. So, lahat ng x gagawin kong a. No? So, a cubed minus a squared minus 2a plus 1 over. So, dito naman sa f prime, lahat ng x gagawin kong a. 3a squared minus 2a minus 2. Yan. Type nyo muna sa calculator yan. Tapos, pagtapos na, shift, solve. Press shift. Then, solve. Okay? Tapos, maglalabas yan ng value. Hihingan kayo ng value ni A. Type 0.5. Umpisa, 0.5 tayo, di ba? Type 0.5. Tapos, press equal sign twice. Equal sign twice. Tapos, makakakita kayo ng value ni X. Paano ko i-type? Pwede ko pa ulit, ma'am. I-type mo siya exactly as I have written it. Ganyan mismo. Gamitin mo din yung same variables na inano ko. So, alpha tapos x. Sa kasyo ito, kasyo yan, iho. .99 is incorrect. You should get 0.4444. Apat na 4. Tingnan nyo ulit, ha. Tingnan nyo kung tama yung formula nyo. Huwag nyo i-erase yung formula. Once na-enter nyo na, kunin nyo lang yung value ng x sub 1 and then go back. Yung meron kayong replay, di ba? Balikan nyo yung formula para hindi every time na magko-compute kayo for the next iteration, you just have to enter the value of A. Hindi na pa ulit-ulit ng pagpapasok ng formula. You should be able to get 0.4444, ha? Pag nakuha nyo to, ibig tama yung pagkapasok. Ayan. Okay. Tama na yan. Do not erase the formula. I-back nyo lang. Mamaya nyo na kunin tong error. The error here is 0.0556. Malalaman nyo naman pagka yung error is less than or equal to 0.0001. Makikita nyo agad yan. So just stop if you get that error. Okay, now for n equals 1, so x sub 1 is 0.4444. Shift solve nyo ulit. Now enter for the value of a, 0.4444. You should be able to get 0.4450 right away. Palitan nyo lang. So go back to the formula that you entered and then shift solve ulit. Ayan, okay. May nakakuha ng 0.4450. And then the error between the two is 0.0006. Okay? We need another one. So when n is equal to 2, this is 0.44450. And then shift solve ulit, you should be getting the same value. Shift solve ulit, for the value of A, it should be 0.4450. So same value na ulit yan dapat. Same lang, ma'am. Kasi 'di ba, a while ago ang solution natin ano ba? 0.4450 din. Kaya lang dito, nag-converge tayo quicker, no, ang convergence dito. So ito 0.0000. So we already have satisfied the criteria. Stopping the iteration. Okay? So mas mabilis ang solution using Newton-Raphson. Yan na yun. Ito na agad. Okay, that is really the first positive. So again, dito, ginamitan ko lang na variable a. You can use whatever variable that you like. Yung nasa numerator is the function f. And in the denominator is the derivative of f. Okay, any questions about Newton-Raphson method? Pwede rin sa Canon. Pwede naman talaga sa Canon yan. Pwede yan sa Sharp, kahit anong calculator. Hindi ko lang alam kung ano yung mga functions mo kasi dyan. Unlike sa Casio, meron kasi akong hawak. Kung ang Casio nyo ay yung kulay gray, yung gray sa yung buong calculator is gray, walang ano yun, solve. Walang solve function. So, ma'am, pwede po ulit paano po nakuha yung delta x? Ito. Delta x, yung dito delta x sub 0. Delta x sub 0 is just 0.4444 minus 0.5. Absolute value. So, ito yung 0.0556. Difference lang between the two. Itong dalawa, itong dalawa, itong dalawa. So, yun lang yung delta x. Any other question? So, that's the second open method for root finding. The third one is called secant method. The third one is called secant method. The formula is actually derived from this. So instead of having a tangent line, you'll have a secant line that passes through 2 points in the given curve, y equals f of x. So I will not be deriving the formula anymore kasi medyo mahaba. But it's almost the same as this. Mas mahaba nga lang because it doesn't require for you to differentiate the function. So no derivatives included in the formula, but it's longer. Okay? Wala namang problema ngayon sa mga formulas kasi when you take the quiz, you can open your notes, right? So, this is the formula for secant method. Based on the formula above, so it's x sub n plus 1 equals x sub n minus f of x sub n minus 1 minus x sub n over f of x sub n minus 1 minus f of x sub n. Okay, again, ito yung next estimate. Ito yung current. Ito namang x sub n minus 1, ito yung previous estimate. So you'll be given two initial estimates here not just 1. Kasi meron kang x sub n minus 1 and you have x sub n. So, for this particular example, we'll use the same function or we'll use the same equation, but I will be giving you 2 initial estimates. Okay? Oh, by the way, does this always converge yung Newton-Raphson? Unlike dun sa fixed point, may test pa for convergence, no? This will always converge for a good good initial estimate. Okay? For a good choice of initial estimate. So, kung maganda yung pagpili mo ng initial estimate, this will always converge. Mas mabilis pa siya mag-converge. Okay? Just make sure na medyo malapit yung pagpili mo doon sa pagpili mo ng initial estimate doon sa iyong group. Okay? All right. This is our formula. Okay, solve. Find the first positive root or the smallest positive root. Root of the same equation, x cubed minus x squared minus 2x plus 1 equals 0. Okay, using this method, using the initial estimates, x sub 0 equals 0 and x sub 1 equals 1. Kanina, ang initial estimate natin is a number in between these two, no? 0.5. So now, it's 0 and 1 because we are now sure that in between these two x's, there is a root. Right? So now, ang table natin, so again, with the same stopping criterion, absolute value, absolute error is less than or equal to 0.0001. Okay? Our table will now be consisting of 5 columns and x sub n minus 1. Meron na nun. X sub n plus 1. And of course, the delta x sub n. Okay? Kanina ilang iterations? 3. Now, ilan kayang iterations? Now, I will start with n equals 1, not 0. Kasi, bakit? We have here x sub n minus 1, ano? And whenever x is equal to 1, this becomes x sub 1 minus 1 or x sub 0, which is exactly what is given here. And when n is equal to 1, this becomes x sub 1, no? It doesn't matter, numbering lang naman yun. So yung number of iterations pa rin naman is the number of rows that you have, okay, when you obtain the final answer. Now this will be x sub 2, no? To solve for x sub 2, we have that formula. X sub 2, using your calculator ulit later on. So muna, x sub 2 is x sub 1 minus f of x sub 1. Tapos, x sub 0 minus x sub 1 over f of x sub 0 minus f of x sub 1. Yan, ha? Okay. Ang f natin is this. So, wala nang involved na derivative, no? Ang x sub 1 natin is 1 minus f of x sub 1, substitute 1 for x here in this function. 1 cubed minus 1 squared minus 2 times 1 plus 1. Okay, times x sub 0 is 0 and x sub 1 is 1 over f of x sub 0. So that is 0 cubed minus 0 squared minus 2 times 0 plus 1 minus f of x sub 1. Ito ulit yun. 1 cubed minus 1 squared minus 2 times 1 plus 1. Okay? Sa calculator, calcu. O, gagamitin natin for x sub 0, A. For x sub 1, b. Type ulit ito exactly like this. In your calculator, x equals, x sub 1 natin ay b. Minus b cube minus b squared minus 2b plus 1. Okay? Times a minus b. All over a cube minus a squared minus 2a plus 1. Okay, baka kala triangle. Okay, minus quantity b cubed minus b squared minus 2b plus 1. Yan. Tapos, shift solve. Shift. Then solve. Then enter the values of a and b. Initially, a is equal to 0, b is equal to 1. And then equal sign twice. You should be getting 0.5. Formula. Yan. Okay. Okay, 0.5, no? Obviously, the difference between the two is 0.5 then. 0.5. Okay, now shift solve ulit. This time, ang A mo naman ay 1 and then your B is 0.5. So when n is equal to 2, this is 1, this is 0.5. Ito yung A, ito yung B. What's the value of x sub 3? Shift solve ulit. It's the value of x sub 3 using your calculator. .4286. Okay. 0.4286. 4286. That is correct. And what is the error between the two? So 0.5 minus 0.4286. The error is 0.07. 0714. Okay, for the third iteration, this is now 0.5. A is 0.5, while B is 0.4286. What is x sub 4? Equal to. Shift solve ulit. Yan na ba? 0.4452. 452. Okay, 0.4452. 4452. Okay, the difference between the two latest approximations, 0.4286 minus 0.4452. 0.0166. 0.0166. Okay, now, hindi pa natin nakuha yung stopping criterion. For the fourth iteration, now A is 0.4452. Ano? 0.42. 4286 and B is 0.4452. What is x sub 5 equal to? .4450. So this is now 0.0002. No? Kulang pa rin. Isa pa. Fifth iteration, this is now 0.4452. And this is 0.4450. This is A, this is B. I think this will be 0.4450 again. Which will give us 0.0000. Tama ba? Kindly check. Okay, tama. All right, so it takes 5 iterations, no, for us to get the smallest positive root using secant method. Okay, so pinakamabilis mag-converge is si Newton-Raphson. Lahat nakakuha nito. Calculator. Kasi importante kaya yung is ilagay sa calculator yun, no, kasi may hirapan kayo pag hindi kayo nag-enter ng formula. Hindi niyo matatapos yung quiz in 2 hours. Diba? Okay. Ma'am, ano po dapat mode ng calcu? It doesn't matter kung polynomial lang. Pero kung meron kang trigo functions, dapat naka-radians ka. Okay? Kung polynomial na ganito, okay lang. It doesn't matter kung radians degree. Dapat lang naka-radians kapag may trigo functions. Okay? Iba kasi nalabas sa iyo, ano yun? Bakit iba? Baka mali yung formula mo, iho. Kasi wala naman trigo functions yan eh. Kaya it doesn't matter kung naka-radians ka o degrees. Ano yan? Casio ba yan? Pwede mo ipakita sa akin yung formula? Pwede mo picturean para makita ko kung saan ka nagkakamali. Send mo sa akin sa inbox. Kasi hindi ko ma-identify kung saan yung mali mo sinulat. Sige, antayin ko ha. Okay, so after that, punta tayo sa MATLAB. Pakita ko sa inyo yung activity natin. Just wait for a while. Please tell me kung nakapag-send na ha. Inbox. Hindi makapasok sa BBB. Wala pong lumalabas. Ano yun? Lozada. Di ba nandito kanina to? Lozada. Oh, hindi ko naman. Happening. Kanina po di ako magpasok. Ngayon lang dumating yung check the attendance. Asan na si Kalubakid? Tagal po na siya. Para makita din ng iba na hindi makapag-calculate. Yung iba, please pumunta na sa MATLAB online. MATLAB online. Search na lang sa Google, MATLAB online. Tapos, sign up na kayo using your TIP email addresses. Mr. Isanan, ano yan? Casio din yan? Casio din? Mr. Isanan. Lumalabas. Pag ano nga yung sabi ni Mr. kanina? Hindi po iba po kasi lumalabas sa akin. Pero tama yung formula mo, no? Bakit wala kang B? Sa ano yan? Sa secant method ba yan, Iho? Magkaiba kasi tayo, B and A dito. Bakit siya puro A? Sa second method po, ma'am, anong second? Pwede bang buksan mo yung mic mo? Nakakapagsalita ka ba para mas mabilis tayo mag-uusap? Ka na mahiya. Tayo-tayo lang to. Second method, sa secant or sa Newton-Raphson? Newton-Raphson. Second method eh. Titingnan ko yung formula ha.
Ma'am.
Yes.
Yung sa yung unang tinaturo niyo sa calculus po, ma'am.
Ito, Newton-Raphson. Yan. Yung A cubed minus A squared. Pag nag-shift solve ka, gamit yung 0.5 dyan, hindi lumalabas yung 0.4444. Yun ang ibig sabihin. Ha? Shift solve mo yan, tapos enter the value of A. 0.5 muna. Tingnan mo dapat.
Okay na po.
Opo, syempre naman.
Opo. So, tapos lumabas po 0.444.
Lumabas na?
May mali lang po ng type kanina, ma'am. Lumabas na.
Okay. Sige. Okay na.
Thank you po, ma'am. Thank you po. Okay na po.
Okay. Hindi, Bilyones, hindi po i-download. Yung ano lang, MATLAB online lang tayo. MATLAB online lang. Masyado malaki yung file na yan. Asan na yung isa pa nagtatanong? Isanan. Hindi po nalabas yung ilalagay ni ba. Di ba may ganito tayo, no? Katulad itong CalQ. Meron kang shift solve. Isanan. MATLAB sa phone, I think limited lang yung mo. Try mo. I'm not sure. Hindi ako nagma-MATLAB sa phone kasi mahirap siyang gamitin sa phone. Kailangan malaki yung screen mo. Isanan. Naka-offline na naman siya. Oo nga, lagi ka naka-offline dito sa akin eh. So, ayun lang. Kailangan yung shift solve. Pagpasok mo ng shift solve, talagang lalabas. Sa Casio, lalabas dyan yung A. Tapos merong question mark. A, question mark. Pag nakalabas yung A, question mark, i-type mo na agad yung value ng A mo. Ganun lang dapat yun. Pag hindi lumabas yun, baka peke yung calculator mo. Lumabas. Hindi siya nakapag-type doon kanina, kaya ayaw. Yun. Okay? Sino pa may questions? Bago tayo pumunta sa MATLAB. Wala na questions? So, go to MATLAB online. I already have here this, no? Open. Naka-publish naman na yung ano eh. Paki-open yung naka-publish na ba yun? Hindi pa pala naka-publish ito. Okay, sige, pa-publish ko na. Pa-publish ko na ito ha. Lalagyan ko na lang ng deadline mamaya. Okay, kindly open the simulation activity. Pinublish ko na siya. Bigyan ko lang kayo ng idea kung anong gagawin dun sa ano. Di ba lahat kayo nakapag linear algebra, no? Marunong kayo mag-MATLAB, no? Tama ba ako? Pag linear algebra na lahat? Okay. Sige. Paki-open muna yung simulation. So, in the simulation activity, ito yung makikita nyo, no? So, about Newton-Raphson and secant method, may konting discussion, giving you the same formula. Okay, malito dun sa mga notation ha, parehas lang yan. Okay. Using Newton-Raphson method tayo, for example, 1. So, find the root of the function using Newton-Raphson method having initial approximation of 1. So, input the following codes to your MATLAB edit window and name it as newton.m. So, kung ganito siya, dapat, dito siya i-enter. May mga numbering dito. Ito yung edit window natin. So, hindi natin to ginamit sa hindi natin to ginamit sa MATLAB nung linear algebra, no? So, mag-enter ka ng function dito. Parang naka-program siya. So, ika-copy-paste mo lang yung program. Yan, yung code. copy-paste dun sa edit window, and then save nyo siya. Save as newton.m. If you try to look at this, meron na ako sa left side ko. Ginawa ko siya kanina. Tapos, eto na ngayon yung function mo, Newton. So, dapat pag in-enter mo sa command window, kung walang errors yung codes mo, pag in-enter mo sa command window yung Newton, meron ka ng function ng Newton, hihingin niya na sa'yo yung given function mo. Diba function mo, cosine x. Ay. Cosine x. Enter the derivative of the given function, negative sine of x. O, ganyan lang. Tingnan ko muna kung makukuha nyo ng tama yung codes. May enter nyo ng tama yung codes. Ulit. O, galing dito. Copy. Copy, copy, copy. Copy, Control C. Sa edit window, dito yung may numbering sa gilid. Paste. Paste. Magiging ganyan. Save. Save. Tapos, ang gagamitin natin ay newton.m. Ay dapat magkaroon kayo ng ganito sa left side.
Ma'am, pwede pong paulit.
Ayun nga, inulit ko na nga. Ulit-ulit. One more time.
Sorry po, ma'am. Nawalan po kasi ako ng internet.
Nawala ka ng internet. Okay.
Opo. Sorry
So,
po.
nasa MATLAB ka na.
Opo, ma'am.
Nakikita mo na tong edit window mo. May mga numbers sa gilid. Kung wala, new, tapos script. Lalabas dito.
Okay po. Wait lang po.
Sige. Tapos paste mo yung nasa simulation activity natin. Ito. Yung Newton Raphson muna. Okay na? Tapos, pagka na-paste na dyan, save. Ang gagamitin mong file name, newton.m. Okay? Tapos, i-run mo yan. Itong run na to. Or dito, run. Okay, parehas lang yun. Right-click, run. Click, right-click, run. Ma'am, yung akin wala po numbering sa gilid. Hindi yan ano. Ito yun, command window yun. Kung hindi siya, wala siyang numbering dito. Hindi sa command window. Mag-new ka, new, tapos script. Okay?
Ma'am,
Oh.
error po.
Yes. Ano error? Na-enter mo na. Dito lang yan, magkaka-error yan dito.
Pagka-run po, error yung lumabas.
Anong nakalagay na pula? May nakasulat dyan error. Anong line yung error?
Error file newton.m line 7 column 13.
Line 7. Okay. Ang nangyari kasi dyan, kung pinis mo yan, no? Ito yun, ano? Pinis ko to, sa line 7 mo, putol. Iakyat mo to. Dyan. Tapos ito din, iakyat nyo. Ito, iakyat nyo to. Yung nasa line 21, iakyat nyo sa 20. Yung nasa 24, iakyat nyo sa 23. Tapos, ito. Nasa line 27, akyat ulit dito. Para buo siya. Line 30, akyat sa 29. Para isang buong linya. Putol-putol siya. Tapos, tsaka nyo i-save. Newton.m.
After po i-run, ilalagay na po yung cosine x.
Di ba nakalagay na enter the given function? Meron na ganon? Ayun na. Ayan, according to the activity, ayan, enter the given function, cosine x, tapos lalabas lahat yan. Type nyo lahat ito, cosine x, negative sine x, 1, 30.001.
Okay po, ma'am.
1. Lalabas siya ng output. after fourth iteration.
Excuse po. After po ma-paste is save po, no?
Save mo, newton.m.
Thank you po.
Puro error. Kurt, kung puro error, yun lang yun. Tingnan mo yung mga lines niya, sasabihin niya kung saan line yung may error. Tanggalin mo yung mga spaces or yung nasa next line, i-transfer mo doon sa previous line. Katulad ng ginawa ko para tuloy buo yung code niya, no? Okay? So, ang ginawa natin dito, nag-program ka ng panibagong function kasi walang function for Newton-Raphson method. So, para meron ka ng command na Newton. Tuwing i-enter mo sa command window yung Newton, hihingan ka niya ng function. So, kahit anong function na ngayon, pwede mong i-solve by iteration method using Newton-Raphson. Okay, so it is the...
Sa output? Ano po yung ilalagay, ma'am, sa output? Yung
sa output, ito.
Yung approximate solution lang? Or yung mismo sagot?
Fourth iteration, ito siya. Ano bang hinihingi doon? Pag hindi naman, write the output below. Sulat mo lang kung ano yung output na nakuha mo.
Okay po.
Ibuo mo yan, diba?
Okay po. Thank you.
Okay.
Yung po, ma'am, gagayahin nyo na sa template po. Yung,
so, ganun din sa secant method, no? Gagawa ka ng function for secant method. Same thing. So, ibang file name lang. Iba yung magiging, So, ang command mo rin dito ay secant. Secant naman. Anong pina-enter ko? Run the following. So, ganun din. Write the output below. And then, answer the questions below. So, ganun lang yung pag-enter ng mga functions. Shared code. Nasa yan? Activity sheet. Ayan, Ayan. Pinablish ko na yan para makita nyo na. I-due date ko to ng Tuesday na lang siguro. Tuesday na lang. Due date ko ng Tuesday. Nalagyan ko ng due date mamaya. Ba't puro line 6 yung error? Tingnan mo yung line 6 mo, iho. Baka meron kang error. Tingnan mo. Tingnan mo yung line 6 mo. Tinry ko na lahat. Ayaw pa rin eh. Tingnan mo. Kasi isang symbol lang mawala dyan. Di yan papasok. Tingnan mo yung mga maliliit na symbols mo. Yung apostrophe, yung semicolon. Character vector is not terminated. Meron ka sigurong na-erase na na symbol. Kasi dapat i-terminate mo lahat ng mga mo. Tingnan mo dito, terminated lahat. Terminated siya lahat. Tingnan mo. Character vectors terminated lahat yan. So, i-copy paste mo ulit. Baka may na-erase ka na maliit na symbol na hindi mo napansin. Okay. Input, enter the given function. Error in Newton, line 6, Y, input, enter the given function. Okay. Hindi siya nag-ano. Tingin ko nga. Tama naman yung mo eh. Tama eh. Iho, try mo na lang, Kurt, i-try mo i-copy paste ulit yung ano. Kasi baka may na-erase tayo dyan. Input initial approximation 1. Babasahin nyo tong ano, oh. Babasahin nyo tong activity. Ayan, oh, initial approximation 1. Ma'am, ano po? Ma'am, pwede ba makahingi ng pic ng code nyo? Code ko. Ito nga, yung code, nandoon siya sa activity sheet. Ito yun, oh. Nandito siya. Ito na siya. Yan siya. Pinublish ko na. Sa simulation 1.1 Newton Raphson and secant method. Pinublish ko na, makikita nyo na dapat yan sa ano nyo, module nyo. Yun nga po eh, paano yun? Anong paano yun? Lang ha. Mga screenshots. No. Yes. Hanggang 11:59 kapag assignment at saka MATLAB